Press the bell icon on the YouTube app and never miss another update.
Today we are going to discuss some basic concept on electric current of class 10th. Now we have electric current. Here the word electric represents electric charge or electricity, and current represents a flow, right? So electric current means a flow of electric charges in a given direction, just as we know air current, flow of air, and water current, flow of water. Similarly, we are having electric current. Electric current is a form of energy which can be easily converted into any other form of energy with the help of what is called as electrical components and electric circuits. For example, we are using so many electrical appliances in our home, right? For example, electric bulb that converts electrical energy into light energy, electrical iron box that converts electrical energy into heat energy, electric fan that converts electrical energy into mechanical energy. So many devices we are using. Even when we are using a TV, we are using electric current. When we are using a remote controller, we are using electric current. And a remote controller will not work without cells. You know the fact that one, right? Now, before going to understand exactly what is electric current, we need to know some basic conditions, because we know that heat always flows from a point of higher temperature to a point of lower temperature. If 2 points are at same temperature, then there will be no flow of heat between those 2 points. For the flow of heat, we need to maintain one point at higher temperature and the other point at lower temperature. Similarly, now a liquid like water can flow from a point of higher pressure to a point of lower pressure, right? So water can flow through the pipe in our homes only when the upper tank is filled with water. If there is no water in that one, so there is no flow of water in the pipe, right? So similarly, for the flow of electric current, electric charge, we need a potential difference, right? Now here the important terms what we are going to use in the electric current, basics of the electric current is flow of electric charge, conductor, potential difference, a source that provides a potential difference, that is a cell, etc. Right? So first we will understand what is electric charge. Electric charge. We know that two bodies of masses attract each other, and that force is called as gravitational force. Whenever a stone is dropped from certain height, it falls towards ground because of gravitational force exerted by earth on that stone. And whenever we consider two magnets, a magnet consists of south pole and north pole, right? Let me consider two magnets. When two south poles of two magnets are brought nearer, they repel each other. When north poles are brought nearer, they repel each other. When south pole and north pole are brought nearer, they attract each other, right? North poles are called similar poles or like poles. South poles are also called like poles or similar poles. But a south pole and a north pole is called as unlike poles or opposite poles. Here, there is a magnetic force of attraction or repulsion between two magnets, right? Similarly, right, whenever there is a electrical force is exerted, and that is due to electric charge. To understand what exactly the electric charge is, from the modern point of view, we know that atom consists of three kinds of fundamental particles: electrons, protons, and neutrons. Of course, hydrogen atom does not contain neutron. It has only one proton and one electron. Except the hydrogen atom, all other atoms contain three fundamental particles. Now, those three fundamental particles are electrons, say E, protons, say P, and neutrons, say N, right? So when we consider, right, electrons, protons and neutrons outside an atom, then they are called isolated particles. When we bring two protons nearer, right, they repel each other, they move away from each other. When we bring two electrons nearer, right, they again repel each other. Just like two north poles repel each other, two south poles repel each other. When we bring a proton and an electron nearer, right, so they attract each other. They attract each other. So, neutrons do not show this property of attraction or repulsion with any other particles. Only protons and electrons have the property to exert the force of attraction or repulsion. This force of attraction or repulsion between electrons and protons is called electrical force. Electrical force. For an instance, force between two masses is gravitational force. Force between two magnets is magnetic force. Force between two charges is at rest is called electrical force or electrostatic force. Then these two particles, right, electrons and protons are called charged particles. They are called charged particle, and they possess one of the fundamental properties of material bodies. That property is called electric charge. So, electric charge is a property possessed by only electrons and protons, right, inside the atom or outside the atom, right. They exert electrical force of attraction or repulsion, right, and this electric charge is a physical quantity. Anything which can be measured and expressed in terms of a numerical value is called as physical quantity. For example, length, mass, time, force, work, energy, power, etc. Electric charge is a physical quantity, right, which can be measured and expressed in terms of a numerical value and an appropriate unit, right. So here the SI unit of electric charge is coulomb. SI unit of electric charge, or simply called charge, is coulomb, and it is represented by the symbol capital C, right. We will define Coulomb later. Now here, whenever we consider the electric charges due to protons and electrons, we observe that at given distance the magnitude of force of attraction or repulsion is same. That means the magnitude of charge on proton is same as magnitude of charge on electron. Both have same quantity of electric charge associated with them, but their nature is exactly opposite, right? So proton repels another proton but attracts electron. Electron repels another electron but attracts proton, right? So these two charges exactly are opposite in nature, right? Therefore there are two types of charges. There are two types of electric charges. Now by conventionally, right, the charge of proton is called positive charge and the charge of electron is called negative charge, right? So we have proton has positive charge and electron has negative charge, right? Now charge of proton is generally represented by plus E and charge of electron is generally represented by minus E. Plus E is a standard symbol for, right, charge of proton and minus E is a standard symbol for charge of electron, right? Now here magnitude of charge, magnitude of electronic charge we call it is magnitude of electronic charge, right, is generally represented by E, right? And the experimentally the value of E is found to be 1.6 into 10 raised to the power of minus 19 coulomb. This you have to be remembered here. Experimentally measured value of electronic charge is 1.6 into 10 raised to the power of minus 19 coulomb. That means to say the charge of proton is plus 1.6 into 10 power minus 19 coulomb and charge of electron is minus 1.6 into 10 raised to the power of minus 19 coulomb. But when we consider the magnitude of charge alone, we take the value E is equal to 1.6 into 10 raised to the power of minus 19 coulomb. When we take the nature of charge, then we will take positive charge plus E, negative charge minus E for proton and electrons respectively, right? Now let us define 1 coulomb of charge. Right. Now before defining the charge, right, we will consider another thing, right, before going to that definition, right? Now when we consider an atom, it is a normal atom consisting of equal number of protons and electrons. For example, we are having carbon atom. When we consider carbon atom, it consists of 6 protons and 6 electrons. 6 protons have total charge of plus 6e and 6 electrons have negative charge of minus 6e, right? Therefore we have charge of atom is, right, it is represented by the standard symbol Q. That is, except charge on proton and charge on electron, the charge of any other body, an atom, a molecule, a body, is represented by the Q. Q is equal to plus 6E minus 6E is equal to 0. That is, a normal atom is electrically neutral. It has neither positive charge nor negative charge. It does not attract any other particles or repel any other particles, right? But the thing is, somehow if we can able to remove an electron from the normal atom, right? So if one electron is removed from the atom, then the charge is equal to plus 6E. Now we are having one electron is removed. The atom is left with only 5 electrons, right? Minus 5E, that is equal to plus E, right? And now that atom has becomes positively charged. Atom has become positively charged, right? Because of deficiency of one electron. If we remove 2 electron, then the charge becomes plus 2E. If we remove 3 electron, charge becomes plus 3E, right? If we remove n electron, charge becomes, right, Ne, right? So if n electrons are removed, then the charge Q is equal to plus Ne, right? So when n electrons are removed from a body, the charge on the body is, right, plus Na, right, where the value of E is 1.6 into 10 raised to the power of minus 19 coulomb. Similarly, if one electron is added, then the charge of the same atom becomes plus 6E minus 7E, because we have added one electron, that becomes minus E. So now the atom becomes negatively charged, right? So when electron is removed, it becomes positively charged. When electron is, right, added, it becomes negatively charged. So if n electrons are added, then the charge becomes Q is equal to minus n into E, right? Clear? So where n is number of electrons, right? Now how to charge a body, right? Body is electrically neutral under normal conditions. Suppose this jack is, right? It is electrically neutral. It is neither positively charged nor negatively charged. Suppose if I remove some electrons, right, from this jack pin, say n electrons, it has a deficiency of electrons and its charge becomes Q is equal to plus Ne. On the other hand, if I add electrons, say n number of electrons, it has n number of excess electrons and the charge becomes Q is equal to minus Ne, right? So in general, right, the charge on a body, right, is So in general, charge on a body Q is equal to, right, Ne, plus or minus Ne we can take, plus for positive charge and minus for negative charge. It is one of the, right, important equation. Q is equal to Ne, charge on a body is equal to, right, integral multiple of electronic charge, where you know the value of E, 1.6 into 10 raised to the power of minus 19 coulomb, right. Now define coulomb. Definition of coulomb, that is C. Now we have, right, so charge of n electron, suppose we are having n number of electrons, right, then the charge on n number of electrons Q is equal to n into E. Suppose if Q is equal to 1 coulomb, right, then we have n is equal to Q by E, Q is equal to 1 coulomb and E is equal to 1.6 into 10 power minus 19 coulomb. Coulomb get cancel. Now n is equal to, right, if we take this 10 power minus 19 to the numerator, it becomes 10 raised to the power of plus 19, and it can be written as 10 into 10 raised to the power of 18 whole divided by, right, 1.6. When we divide 10 by 1.6, we get 6.25 into 10 raised to the power of 18. It is quite a large number. So the charge on a body is 1 coulomb when we add or remove 6.25 into 10 raised to the power of 18 electrons. Therefore, 1 coulomb of charge is constituted by the total charge of 6.25 into 10 raised to the power of 18 electrons, right? And that is the definition. Using this one, we can calculate how many number of electrons constitute 2 coulomb of charge, how many electrons constitute 1.5 coulomb of charge, how many electrons constitute 10 coulomb of charge. The formula is same. N is equal to Q by E. So Q is the given charge, 1 coulomb, 2 coulomb, 3 coulomb, or then it is 1.6 into 10 power minus 19. So now for 2 coulomb it becomes 2 times. For 3 coulomb it becomes 3 times, 6.25 into 10 power 18. Now, let us understand a term, that is electrification. Right. The process of charging a body is called as electrification. By adding or removing electrons from a body, right, we can charge the body. When electrons are removed from the body, it becomes positively charged. When electrons are added to a body, it becomes negatively charged, right? There are so many methods of electrification, that is by adding or removing electrons. One of the method is electrification by friction, right? Now we see that. Let us take an example. Let us take a comb and small pieces of paper or straw. When we bring that comb near the small pieces of paper, here small pieces of paper, here we have a comb, right? Now there is no force of attraction between them. The comb will not attract the paper pieces because its charge is 0. So when the same comb is rubbed against dry air, right, then we will bring that comb near the paper pieces. Now the comb attract the paper pieces, right? It is because now the comb has acquired electric charge due to addition or removal of electrons from it. In a similar way, when we take that glass rod and rubbed against silk, when they are rubbed against silk, now the electrons flow from, right, glass rod to silk. As a result, glass becomes positively charged and this silk becomes negatively charged, right? So we can charge any body, right, by adding or removing electrons from it, and that a body is called charged body. Now it is capable of exerting electrical force of attraction or repulsion between them. I think now we have a clear picture about electric charge. Electric charge is a fundamental property possessed by electrons and protons. The bodies can also acquire the properties of electric charge when they have unequal number of protons and electrons. Protons cannot be removed from the atom because they are held tightly by the nucleus, but electrons can be added or removed from the body, right? Now to understand further concepts, right, we need to understand two things. Now depending upon electrical properties, right, these material bodies are classified into two types. Number one, conductors, right, and number two, insulators, right. Any substance that allows electric charges to flow through them is called as a conductor, right. Now the well-known conductors are metallic conductors like copper, silver, iron, right, and the alloys like nichrome, manganese, right. Now carbon in the form of graphite, right, impure water, all are, right, called conductors. For example, we take metals, alloys, right, graphite, human body, right. Now the metals are good conductors because they have free electrons in them, right. When we take metals, a piece of metal, now we know that in an atom, right, the electrons are revolving around the nucleus in various orbits. The electron in the outermost orbit is called as valence electron. Now in case of metals, the outermost electrons, electrons in outermost orbits are loosely bounded to the nucleus. Electrostatic force of attraction is very less. They can easily escape from the atom and move through interatomic space between the atoms, right? These electrons are not revolving around the nucleus of an atom, right? They are moving through interatomic spaces, right, within the surface. These electrons are called free electrons, right? Now these are atoms, right, that have lost electrons, and there are large number of electrons. In some metals, one atom contribute one electron. In some metals, one atom contribute two or more electrons, right? Now this electron, right, is moving through interatomic spaces, right? Therefore, metals are good conductors of electric charges. When a metal is charged, these electrons move the charge, right, through the conductor, right? Therefore, in electric current, we use metallic conductor for the flow of electric current. Is it clear? Why metal is a good conductor of electricity? Because of the flow of electrons. And another thing is, here the electrons, right, flow, right, in random direction, right? There are large number of electrons. They are moving in random direction. They are colliding with the atoms, right, etc. But though electrons are moving in a conductor, right, ordinary conductor, without any arrangement in it, right, these motion of free electrons, though the free electrons are charged particles, does not constitute electric current, right? We will discuss it right in the next concept. And a substance that does not allow electric charges to pass through it is called as an insulator, right? Now we are having a rubber, plastic, wood, mica, dry air, etc. are insulators. They do not allow electric charges to pass through them, right? So in the process of conversion of electric current into any other form of energy, we need both conductors and insulators. Insulators are used for safety purposes, right? Now the question is, why insulators do not allow electric charges to pass through them? In insulators, all the valence electron, there it is either completely filled or half filled, right? Therefore, they are tightly bounded to the nucleus and no electron escapes from the atom. And insulators do not have free electrons, therefore they do not allow, right, electric charges to pass through them. Whereas in metals, the outermost orbit is partially filled. It is neither half filled nor completely filled, right? Therefore, the atom is unstable and electrons can be easily come out of the atom and move throughout the metals through interatomic spaces within the surface, right? Now, this conductors and insulators both can be charged, right? Suppose, say, we are having a metallic sphere, say a shot put. If we add some electrons, right, say we have added, say, 4 electrons, there is a mutual force of repulsion between them. Therefore, they move away from each other and come over the, right, surface of the sphere. Right. Now, when an insulator is charged, say sphere, a cricket ball, right? So when the same 4 electrons are added, right, now these 4 electrons do not move, right? They remains localized, they remains in the same position where they have added, but in conductors there is a movement of electric charges. Now the concept of metallic conductors and the free electrons and their motion, the collision of free electrons with the atoms are very important in understanding the electric current and resistance of a conductor, right? Resistance means it is the opposition offered by the conductor for the flow of electric current, right? Clear? So we have discussed electric charge, charge of electron, charge of proton, charge on a body, right? Unit of electric charge, that is coulomb. The charge of electron and proton plus or minus 1.6 into 10 power minus 19 coulomb, right? And we have defined 1 coulomb of charge, and we can calculate how many electrons constitute how many amount of electric charge in coulomb. And the two important types of materials, right? Conductors and insulators. Generally, when we consider the conductors, they are the metallic conductors. Metallic conductors contain free electrons. These free electrons are responsible for the flow of electric charges to this them, right?